Hello students, welcome to the cbse chemistry lecture series. In this video we are going to talk about isomerism. So in organic chemistry, one of the most important characteristics of organic compound is their ability to show isomerism. So what is meant by isomerism? Isomerism is defined as two or more compounds having the same molecular formula but different chemical and physical properties. Are called isomers, and the phenomenon is known as isomerism. Next we see the different types of isomerism. There are two different types of isomerism. They are structural isomerism and stereoisomerism. Structural isomerism. Another one is a stereoisomerism. First of all, I will tell you what is structural isomerism. The arrangement of atoms or the length of the carbon chain, then the position of the functional groups, then within the functional group itself there are various arrangement of atoms that we can call as comes under the category of structural isomerism. What is the stereoisomerism? Stereo means the stereo is the what? Arrangement of atoms in space, or you can say spatial arrangement of atoms. Spatial arrangement of atoms. So among these what structural isomerism as well as in the stereoisomerism, we have lot of different kinds of isomerism existed. So what are those types of isomerisms? One, chain isomerism, or you can say nuclear isomerism. Secondly, position isomerism. Third one is a functional. Fourth one is a metamerism. Fifth one is a tautomerism. But in the case of stereoisomerism, we have only two isomerism. One is a geometrical isomerism. Second one is a optical isomerism. So let us discuss one by one. Yes, let us discuss structural isomerism. First we will define what is meant by structural isomerism. Compounds having same molecular formula, shorter we can say MF, but different structures. Or you can say a different arrangement of atoms within the molecule are called isomers, and the phenomenon is known as structural isomerism. In that structural isomerism, we are having a various types of isomerism are possible. First we will take a chain isomerism. In that chain isomerism, first we will see the definition. What is meant by chain isomerism? Compounds having the same molecular formula but different arrangement of carbon chain within the molecule are called chain isomerism. How can I define it? We can write the definition first. Compounds having same molecular formula MF but different arrangement of carbon chain. Arrangement of carbon chain. Within that molecule, within the molecule, called chain isomerism. So we will take some examples. Okay. So we will take a example, molecular formula C4H10. C4H10. We will write at least minimum 2 structures, then only it is an isomerism. So for this case, you have to write what? 1, 2, 3, 4. You have to fill up the hydrogen atoms CH3, CH2, CH2, CH3. These are all in the linear form. If you write an isomerism, 1, 2, 3, 1. So you have to fill up the hydrogen atoms CH3, CH3, CH, CH3. In all these cases, count the carbon atoms. 4 hydrogen atoms, 4 carbon atoms, and 3 plus 3, 6, 6 plus 4, 10 hydrogen atoms. Here also what? 4 carbon atoms. 9, so 10. So in these two structures, what is the name for this compound? This is N-butane. Here it is a 2-methyl, or this is an isopropanol, or you can say a common name is isobutane. IUPAC name is butane, or this compound IUPAC name is butane, and this is what? 2-methyl propane. Yes. And the second one will take a position isomerism. First we will define what is meant by position isomerism. Compounds having same molecular formula but different the position of the functional groups. Say for example, double bond. The position of double bond may be different. Or position of functional groups like what? One OH maybe in the first carbon atom, or maybe in the second carbon atom, or in the third carbon atom. That is called position isomerism. How can I define first? Compounds having same molecular formula but different the position of the functional groups. Difference in the position of the functional group. Say for example, we will take a compounds like C4H8 example. So you have to put what? 1, 2, 3, 4. So fill up the hydrogen atom CH3, CH, double bond CH, CH3. Another one CH2, double bond CH, CH2, CH3. In both these compounds, the position of the double bond is different. Here it's what? 1, 2, 3, 4. So butene. Whereas here it's what? 1, 2, 3, 4. But1ene. In both the cases, the molecular formula is same, C4H8, but the position of the functional group are different. That is called position isomerism. Now we will discuss what is meant by functional isomerism. First we will define what is meant by functional isomerism. Here also organic compounds having the same molecular formula. Same molecular formula but different functional groups. I abbreviated as FG, different functional groups are called functional isomers, and the phenomenon is known as functional isomerism. We will take an example like this one. C2 molecular formula C2H6O. So we can write the structures, functional isomers. So CH3, CH2, OH. This is one compound. At least you have to write a minimum 2 or 3 compounds. So here we can 2 compounds are possibles. In both the cases, see here, carbon, 2 carbon atoms, hydrogen 3 plus 2, 5, 5 plus 1, 6, 1 oxygen atoms. Here C, 2 carbon atoms, oxygen 1, hydrogen is 6. So one is a functional group is what? OH is a functional group, another is a ether is another functional group. So these two functional groups are entirely different. That is why what? Organic compounds having the same molecular formula but different functional groups. So one is a ethanol, another one is a dimethyl ether, or you can say methoxymethane. Dimethyl ether is a common name, or you can say IUPAC name is methoxymethane. Its common name is ethyl alcohol. Then the next functional group is you can say metamerism. Another type of isomerism is metamerism. First we will define what is meant by metamerism. Here also organic compounds having the same molecular formula but different number of carbon chains are with respect to the functional group, like oxygen, sulfur or keto functional group. With respect to the functional group on both sides different alkyl substituents. We will define it first. Compounds having same molecular formula but different number of carbon atoms, or you can say alkyl groups on either side of the functional group, on either side of the functional group. I will take an example for this case. You can take an example of CH3, CH2, O, CH2, CH3. You can think about its molecular formula is what? C4S H10O. Okay, so the arrangement of atoms with respect to the functional group, oxygen atoms, we have on different side different alkyl groups. Say for example CH3O, CH2, CH2, CH3. So with respect to the functional groups on both sides, you see the number of carbon atoms. Sorry, here it's a 2 carbon. Here it is all 2, 2. Here it is what? 1, and here it's a 3 carbon atoms. That different alkyl group substituents with respect to the functional group, ether functional group. The one is a ethoxyethane. The IUPAC name is ethoxyethane. The another one is what? Methoxypropane. These two are metamerism. So now you clearly understood that what is a metamerism? Compounds having the same molecular formula, both are having the same molecular formula C4H10O, but with respect to the functional group oxygen, on both sides we are having different alkyl substituents. Then it is called metamerism. We can write one more structures also possible. So CH3, CH, CH3, OCH3. So this is also another metamerism. So here you got say 2 methyl, you got number the carbon atoms, 2 methoxy propane. Okay. Yes. Next we will discuss tautomerism. Is also another kind of structural isomerism. What is a tautomerism? The tautomerism arises due to 1,3 migration of a hydrogen atom. 1,3 shift we can call this migration of a hydrogen atom from one polyvalent atom to other within the molecule itself. That isomers we can call it as what? And that exists in the dynamic position, or you can say dynamic equilibrium with each other, are called tautomers. And the phenomenon is known as tautomerisms. We will take one examples. Say for example acetaldehyde, CH3, CHO. Here you have to write like this: CH3, C, double bond OH. So you have to see the positions 1, 2, 3. Here the first position or hydrogen atom is migrated to form OH form. So this we have to write like this: CH2 double bond C OH and H. And this one is a keto form. This one is a enol form. So therefore it is a keto-enol tautomers. I'll give another example for this case. Second example, this one is the first example. You can take acetone CH3 C double bond O CH3. Now you have to shift this one, or you can put a arrow mark like this. It is exists in the dynamic positions. Yes, 1, 2, 3. So CH2 double bond COH CH3. This is a keto form. This one is a enol form, keto-enol form. Thank you, students. If you have any doubt, please mention in the comment box. We will see in the next video the stereoisomerism. Thank you.